Hello and welcome to Walking Talking Mocks with Bude Haven Science. The question we're going to look at is going to test your knowledge on bonding, structure and their properties. This is a 9-mark question made up of 3 parts, all focusing on different structures. During this video, you'll be given the opportunity to pause and answer a question, followed by a model answer from me. To answer this question, all you'll need is paper, a pen, and something to time yourself for 3 minutes. To support you in answering this question, we're going to look at the subject knowledge you should have about this topic. Look at the table for the following. Which type of atom is required to make the bond? How the bond forms? What properties the structure would have? And also consider which examples you should know by looking at the diagrams. For a simple covalent bond to form, 2 non-metal atoms are used. For example, the oxygen you can see. In order for this bond to form, electrons in the outer shell are shared. They do this in order to form full outer shells for both atoms. This is why you can see a double bond on the example we've given you. Here are some other examples that you should be familiar with. As you can see, all of these have single covalent bonds between the atoms. These are strong covalent bonds. However, the forces in between the molecules are weak. This leads us on to properties. Properties of simple covalent structures are as follows. They have low melting and boiling points. This is because the energy needed to separate the molecules are small. You need to be very specific when you explain this in an exam. The covalent bonds which hold the 2 or more atoms together are exceptionally strong, but the forces in between 2 pairs of molecules are very weak. See this diagram. For this reason, simple covalent structures are going to be gas or liquid at room temperature and pressure. Now we'll move on to giant covalent structures. Again, these require non-metals, however, unlike simple covalent bonds, many atoms will be used in the structure. Your examples are as shown: diamond, graphite, silica and fullerenes. As you can see, these contain many carbon atoms. They require the electrons to be shared in the outer shell to form the bond. So, it's important to remember that carbon can form 4 bonds. This is relevant when talking about its properties. Its properties are as follows: high melting and boiling point, insoluble in water, they're always solids, and they do not conduct electricity, other than graphite. This is where the relevance of the carbon bonds fit in. As carbon can form 4 bonds using its electrons, and graphite only has 3 covalent bonds, there is a spare electron. This electron is what allows graphite to conduct electricity. You may also be asked to explain why there is a high melting and boiling point in giant covalent structures. This is due to the many atoms present in a giant covalent structure. As these are covalent bonds, they are very strong, and as there are many, a lot of energy is needed to overcome these bonds. The next structure we're going to look at are metallic lattices. The atoms required for these to form are all metal atoms. They form by the outer electrons becoming delocalized, as you can see on our diagram. When these become delocalized, a plus ion forms. This is given its name an ion because it has now got a charge. So the atom has a plus charge and the sea of electrons amongst it have a negative charge. This creates a strong electrostatic attraction, causing the structure to be exceptionally strong. The properties of the structures are as follows. Very high melting and boiling point because a lot of energy is needed to overcome the bonds. They are good conductors of heat and electricity. This is due to the delocalized electrons that you'd find amongst the structure. They are insoluble, they are also strong. They are malleable, which means they can be hammered into shape, and they are also ductile, which means they can be drawn into long wires. The last type of bond to consider are ionic bonds. These occur between metals and non-metals. You will have seen this in the salts you have made. For example, sodium chloride, table salt. When this bond forms, electrons are donated from the atom with the least electrons in the outer shell. This will always be the metal. The electron is received by the non-metal. Because electrons have moved, we can now refer to these as ions. So the atom that donated an electron has now become slightly positive. The ion that has received the electron has now become slightly negative. This creates a strong electrostatic attraction between the two ions, making it difficult to break up. Therefore, the properties are as follows. Solids cannot conduct electricity because the ions cannot move. If you would like an ionic compound to conduct electricity, it must be in two forms, either molten, which means it's been heated up and now becomes slightly liquid, or dissolved in water as a solution. These are the only two occasions on which ionic compounds can conduct electricity. If you look at the diagram, you can see how this bond forms. You're now being given the opportunity to answer three 3-mark questions related to the subject knowledge we have discussed. I will ask you to pause the video for 3 minutes, so I suggest you time yourself to get into the habit of answering under exam conditions. I will now read you the question. Here is the first 3-mark question. This question is about structure and bonding. Figure 1 shows part of the structure and bonding in diamond. Explain why diamond has a high melting point. Pause the video for 3 minutes and an example answer will follow from me. Here is an example answer to this question. I've underlined the parts that I think are most important to answering the question. Diamond is an example of a giant covalent structure. There are many carbon atoms with strong covalent bonds between them, and a lot of energy is required to overcome the many strong covalent bonds. Here is the second 3-marker. Figure 2 shows part of the structure and bonding of sodium chloride. Explain the conditions needed for sodium chloride to conduct electricity. Again, pause the video for 3 minutes to attempt your own answer, and then an example answer will follow from me. Hopefully your answer has included some of the following. A solid ionic lattice cannot conduct electricity. They must be in molten or solution form for the ions to move freely. This enables electricity to flow through the negative charge. Because the question has asked us to explain, we've given a reason and said why. Here is the final 3-marker in this 9-mark question. Figure 3 shows the structure of sodium. Describe how sodium conducts thermal energy. For the last time, pause the video to answer the question yourself, and again, an example from me will follow. In this final question, you've been asked to describe, which means to give an account of what happens. So my answer is as follows. This is a metallic lattice. There are delocalized electrons between the metal ions. The freely moving electrons are able to carry the thermal energy through the lattice. I hope that you have found this video helpful. If you are still struggling to understand structure, bonding and their properties, please see your teacher or come to our Wednesday revision sessions for additional support. Thank you.